All right, guys. So we're gonna start our discussion on the F3, FP3, chapter one, hyperbolic function. Okay, right. So the first thing we'll be doing here is we will be introducing you to hyperbolic function. So previously you've been working a lot with trigonometric functions, right? In P3, the P1, P2, and basically in the previous further mathematics, we were mainly working with trigonometric functions, exponential functions, right? So those were the ones that we normally work with. But now we are going to introduce you to hyperbolic functions. So hyperbolic functions have several properties in common with trigonometric functions. So they are kind of have some similarity, but they are defined in terms of exponential functions. So this is the difference. Okay. So the hyperbolic functions, they look, I mean, the properties are kind of similar with trigonometric, but the way they are defined, that's what makes the difference. All right, guys. So the first one, so we're introducing you to the hyperbolic function, the hyperbolic sign. Okay, often pronounced shine. So the way the pronunciation is what makes, the pronunciation is different. So you can see is defined as shine x equals e to the power x minus e to the power minus x divided by 2. So guys, what we do here is we are introducing you to several types of hyperbolic functions. Okay, and then what we'll be doing here is after introducing you to all of these types, we will be discussing the properties of each and every one of these types of hyperbolic function. Like we're going to discuss about the graph, we're going to discuss about the hidden properties inside of each and every single hyperbolic function. Okay, so first what we'll do is we'll just give you a brief introduction. So basically, shine x is e to the power x minus e to the power minus x, whole thing divided by 2. And then the next one, hyperbolic cosine, often pronounced as cosh. Can you see the way? So cosh is defined as, so cosh x is equal to e to the power x plus e to the power minus x, the whole thing divided by 2. Okay, and then the next one, hyperbolic tangent. Okay, often pronounced as tang or tan. Okay, so the pronunciation you can choose any you prefer. So tan x is equivalent to shine x over cos x. So this is where you have the similarity. Can you see? Because you know in trigonometric, okay, tan x or simply tan theta is sine over cos, right? So in here you can see even the hyperbolic tangent, or we call tan x, is sine x over cos x, right, guys? So there are some similarities. And then what they've done here is that you can see this particular step of simplification should be clear to you, right? So they've taken shine x and divided by the cos x. So I know shine x is this particular expression. Cos x is this particular expression. So we divide. And you see, guys, so when you divide, the two cancels out, and you can see that you get this particular expression. Shall I simplify and show you guys? It's a pretty straightforward simplification. Tan x is shine x over cos x. So shine x is e to the power x minus e to the power minus x divided by 2, right, guys? The other one, e to the power, so cos x is e to the power x plus e to the power minus x, whole thing divided by 2. And then, guys, you can see the 2 can cancel out. And you get here e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. So this is the simplification. So we can simplify this a little bit more. So the way I'm going to simplify this a little bit more, so I'm going to consider, I'm going to take this particular expression and I'll multiply the the numerator and denominator everyone with e to the power x. Okay, so this is just an attempt at simplification. Okay, so I'm going to simplify both up and down, multiplying by e to the power x. So what happens here? So e to the power x into e to the power x, that's e to the power 2x, right? The powers add. Minus e to the power minus x into e to the power x. So you know the powers add and it gives you e to the power 0. Right, guys? E to the power 0. Because when you add e to the power minus x, when you multiply, you get here e to the power 0. So e to the power 0, any number, the power of 0 is 1. Divide by the same story here. Ex into ex is e to the power 2x. plus over here e to the power minus x into e to the power x. That's again going to be e to the power 0. So that's going to be a 1. All right, guys. So this is an attempt at simplification. So as you can see, okay, so this is kind of like the final expression that we get for tangent x, e to the power 2x minus 1 over e to the power 2x plus 1. All right, guys. Okay, and then the next part, there are also hyperbolic functions corresponding or connected to the reciprocal trigonometric function. Do you recall reciprocal trigonometric functions? So that something you learn in P3, right? So reciprocal of sine is cosec, so cos is sec, and reciprocal of tan is cot. Do you recall? So the same thing again. So we're going to go with the same thing. So the hyperbolic cosecant or cosec, so often pronounced as cosec, or so the pronunciation you can choose any as you prefer. So cosec x is actually what? It's the reciprocal of sin x. Right, guys? So cosec x is the reciprocal of sine. So you can see they've flipped the fraction. So that's it. And then hyperbolic second of we can pronounce it as sec x. All right, guys. So that's equivalent to the reciprocal of cos x. So you can see we turn this fraction upside down. And then finally, the hyperbolic cotangent. Okay, also we pronounce, we say it as cot x. That is 1 over tangent x. Right, guys? So can you see this fraction? You simply take the reciprocal of it. Right, so these are the these are the hyperbolic functions that you need to know. So we are going to be looking into the properties of these guys in the next part of the, we're going to discuss all the properties, the graphs. Okay, so in the next part of the lesson. All right, guys. So I've taken the definitions here. So we'll move on to the first exercise. So they say use your calculator to find 2 decimal places the value. Okay, so they've given you these guys. You have to find the values to 2 decimal places. So all you got to do here is, guys, take the calc. Okay, so in order to type shine 4 in the calculator, guys, the way you do it. Okay, so let me first set the calculator to the normal mode. Okay, so now this is the normal mode of the calculator in degree mode. So all you got to do is, guys, so you'll find this, you need to find this option in your calculator. So I can see here HYP. So HYP means it's going to get me the hyperbolic function, right? So over here, I hope you guys can see where I'm pointing. So I press that button and you can see when I press that, I get all these functions. Can you see? Shine, cosh, tanch, and I even get the inverse. Okay, so at this point, first we are going to learn how to deal with the normal function. We'll go to the inverse afterwards. So I want to get the value of shine 4. So I give 1 and I get shine, and then all I have to do is just give 4. Shine 4 and then give the equal mark, and I get the answer 27.29. All right, guys, can you see? So the answer is 27.29. So guys, also you can now we got the answer from the calculator, right? By the way, you get this answer in the calculator regardless of the mode of the calculator, whether it's in degree mode or whether it's in radian mode. You get the answer regardless of the mode, right, guys? So you can see now it's in radian mode, and we still get the answer the same one. So why we get the same answer? It's because as you see, these shine, cosh, all these hyperbolic functions are defined in terms of exponential terms. Right there. So let's also do this manually. So if I want to get the value of shine 4, we know shine x is. Okay, so I want to get the value of shine 4. So shine 4 is e to the power 4 minus e to the power minus 4 divided by 2. Guys, can you see? So I'm just substituting the x value into this expression. I want to get the value of shine 4. So simply replace x with 4. And then you can give this in the calculator. So e to the power of 4 minus e to the power minus 4. And then you divide the whole thing by 2. All right, guys. And then you can see, so when you get the answer, it's exactly the same answer that we got, right? So these are all inbuilt in the calculator. So you can directly, the calculator can directly do this for you. Or else you can always, type the function manually and still get the answer. All right, guys? All right, guys. So similarly, you can get the answers for the other parts as well. So cosh half. So you press this button hype and you give cosh and you can give half. 0.5 or 1 over 2. Right, guys, and you can get the answer 1.1276. So to two decimal places, 1.13. All right, guys, and then tang, third one. So -2. Can you guys see? So it's really simple to give this in the calculator. And then how do you give such? Now, by the way, you don't have, now you can see when you give the hyperbolic function, okay, you can see that you have the three main functions, so sine, cos, and tan. Okay, so that's what you have, but you don't have the other, the reciprocal functions are not there. So you'll have to do it manually, right? So if you want to find the value of sech5, sech is the reciprocal of cosh, right? Sech is the reciprocal of cosh. So all you have to do is 1 over, okay, you give 1 over, all right, and then you give this guy hype and you go for the cosh function, right? Because you can't directly give sech in the cap. So 1 over cos 5, and this is, in other words, sech5. All right, guys, 0.01347. It goes on, right? So you can correct it to it is 0.01. All right, guys. Okay, so we'll move on to question number 2, write in terms of E. Okay, so that means here they want you to give the answer in exact form. So how do you write the answer in terms of E? Question number 2. So shine 1. So guys, we know shine x is e to the power x minus e to the power minus x over 2. So if it's shine 1, it's e to the power 1 minus e to the power minus 1 whole thing divided by 2. All right, guys. So you can simplify this a little bit. E minus e to the power minus 1 is actually a 1 over e. Right, guys? So, I mean, they wanted you to keep the answer in terms of e. Maybe you could keep it like this. Sometimes they'll maybe give you a show that. So maybe you can multiply both up and down by an e term. So this is just simplification, not exactly steps that are a must. Okay, but I'm just showing you a little bit of simplification. So you get this. Right, guys? When you multiply e into e, that's e square minus 1 over e into e, that's just 1. All right, and then divide by 2 times e is 2e. So you do remember, right, that I mean, when you multiply with this, you need to do it to both the numerator and the denominator and to all the terms. That's what I've done here. So basically, it's a equivalent fraction. All right, guys. All right, guys. So I think these stuff are pretty much straightforward, right? So you can type them in the cal and get the answer direct. So sech minus 1. So we'll do that one. So in the case of sech minus 1, so you're supposed to write the answer in terms of e. So just simply substitute that the equation, right, guys? So we have the sech x equation. That's 2 over e to the power x plus e to the power minus x. So if I want to get the value of sech minus 1, so all I have to do here is replace the x with minus 1. So 2 over e to the power minus 1 minus e to the power minus 1. So that's a plus 1. Right, guys? So you can actually leave it at this point. Okay, so if you want to get rid of the negative power in the negative power of e, you could multiply both the numerator and denominator by an e. So as I did over here, but these are like not compulsory steps. So we are right at this point, we're at the beginning of the lesson. So I was just trying to show you a little bit of simplification. Okay, so you can, it's perfectly fine to leave the answer like this, or you could multiply both up and down by an e term. Okay, so that's just for the sake of simplification to get rid of the negative power. Okay, and then you get 2e over 1 minus e square. All right, guys, so that's okay, so that's the answer. Guys, yeah, sech x is actually 2 over ex plus e minus x, right, guys? So this is not a minus, it's a plus in the middle, right? So sech x 2 over ex plus e minus x. So this should be a plus here, right, guys? So that's the difference. All right. All right, guys. So next one. So question number 3, find the exact values of shine ln2. So how do you get the value of exact value of shine ln2? So let's first do this work on this manually because you need to understand what's going on inside. So we know shine x is e to the power x minus e to the power minus x over 2. All right, guys. Shine x is ex minus e minus x over 2. So shine instead of x, we have now the natural log of 2, right? ln2. So replace all the x terms with ln2. So e to the power ln2 minus e to the power minus ln2 divide by 2. All right, guys? Okay, so this is the part that you need to recall, the simplification. So if you recall, so you have this, you should know that e to the power of ln x is directly x, right, guys? So if you have e to the power of ln2, that's directly 2 here. That's directly 2. However, if you have, now over here, you have e to the power negative of the natural log of 2. So there's a negative sign here. So if you have a negative sign over here, or if you have any number, right, I mean, so if you have something like this, I'll just write e to the power 2 ln x. So in this case, you can't immediately go with this rule. So you have to do a little bit of fixing here, right, guys? So do you recall how to fix it? So the way we do it is, it's a logarithm, and when there's a number in front of the logarithm, you can take it inside as a power. All right, guys. So you can get here, you can, rewrite this sum as ln x square. All right, guys. So e to the power ln x square, that gives you directly the answer as x square. All right. So these are really simple proof. Stuff that you've done in P3, P4. So simply that what you get here is e to the power ln2. That's directly 2. Guys, this one, when they read the power minus ln2, so you need to realize the minus means it's a minus 1 here. So take it in. So it's going to be ln2 to the power minus 1. All right, guys, divide by 2. So that's going to be 2 minus 2 to the power minus 1. Whole thing divide by 2. All right, guys. So you can simplify this with the cal. 2 minus half divide by 2. All right, guys. So that's going to give you the answer 3 over 4. All right, guys. All right, guys. So here, this is the answer. So you can see I've typed this in the calculator as well. So shine ln2, and you can see we get the answer directly 3 over 4. All right. So you can get it manually as well as you can get this from the calculator. Okay. All right, guys. So the others are also pretty much straightforward, right? So over here, cos ln3, tan ln3. So you can try this stuff. So let me do part D, cosich ln pi. Okay, so I think you can see now that the question says they want you to find the exact value. But if you try to do this in the calculator for cosec, cosec is 1 over, right? 1 over shine, the reciprocal of shine. Okay, so 1 over shine, and if you try to give ln pi, okay, so are we going to get an exact answer? And you can see that we get a decimal figure here, right? So guys, what we'll do is let's get the answer manually. So let's substitute values into the equation. So what do we have for cosec x? So guys, here cosec x is 2 over, can you see, ex minus e to the power minus x. So that's our expression that we will be substituting. So we'll work with that. Cosec x is 2 over ex minus e to the power minus x. All right, guys. Okay, so let's substitute cosec ln pi. 2 over e to the power ln pi minus e to the power minus ln pi. So again, the same rule applies. E to the power ln pi is directly pi, right? All right, guys. So here again, the same rule, the negative sign, you can take it into the logarithm as a power and you get ln pi to the power minus 1. So e times ln pi to the power minus 1 directly gives you the answer as pi to the power minus 1. All right, guys. So this is minus pi to the power minus 1. So you could leave your answer like this. So entirely up to you, or you could simplify this a little bit more. That's perfectly fine. Okay, so you could leave your answer, or you could multiply both up and down with a pi term, and you can get 2 pi over pi square minus 1. Okay, so any of these two answers are fine. They're equivalent fractions. Okay, so what I did here is to get this particular answer, I multiplied both numerator and denominator by pi. Okay, and I get this. All right, guys. All right, guys. So next we'll attempt question number 4. So they say in these questions, use the definitions of the hyperbolic functions in terms of exponential to find each answer. Then check your answer using inverse hyperbolic functions on your calculator. Okay, so let's try this out. So they say here in question number 4, find the two decimal places the values of x for which cos x is equal to. All right, guys. So we're actually doing the inverse now. So they have told you that cos x is equal to 2, and you're supposed to find what are the x values that can make cos x, the answer of cos x, become equal to. So what's the x value that you need to input here? So simply, guys, you can see x is directly equal to cos inverse of 2, isn't it? Right? So you can see x is cos inverse of 2. Okay. So that's the direct answer in the calculator. Okay, so we'll do that at the end. So first, let's do the manual simplification. So how do we do the manual simplification? We know cos x is, guys, so this is the expression ex plus e minus x over 2. So let's substitute that. Cos x is ex plus e minus x over 2. All right, guys, this is equal to 2. So now it's a matter of simplification. So let's take the 2 to the other side in the denominator. It multiplies, gives you 4. So ex plus e minus x equals 2 times 2 is 4. So taking everything to, okay, so we come to this point. And guys, if you can see at this point, this is actually a quadratic equation. Maybe you might not be able to see it immediately. So what I'll do here is, I'll take this equation, multiply everyone with e to the power x. Okay, if as long as I multiply both sides of the equation and all the terms, so that should be perfectly fine, right? So I'm going to end up getting here ex into ex is e to the power 2x plus e minus x into ex is e to the power 0, 4 times e to the power x. All right, guys, so e to the power 0 is 1. So we get here e to the power 2x minus 4 e to the power x. So guys, I'm taking this over here, okay? So e to the power 2x minus 4 e to the power x plus 1 is equal to 0. So I think you can see now that this is a quadratic equation. Right, guys? Can you see it's a quadratic equation? Right? So this is like your x square minus 4x plus 1. So now time to see this quadratic equation factorizes. So your factorization will happen in terms of e to the power x, right? So this is the smaller power. Okay, so in terms of that. Okay, so you need to find factors. Is it possible? The first thing is it possible to factorize? Okay, let's see. All right, guys. So I think this is a sum that does not factorize, right? So we'll have to go with either completing squares or you have to go with the quadratic formula. So one of the two, either completing squares or quadratic formula. One of the two should work. Okay, so remember treat ex as your x term, or probably you can think of this as, if you want, you can replace. Okay, so this is actually not a compulsory move, but if you want, you can say, okay, let y be e to the power x, or let a something be e to the power x, which means a square is e to the power 2x. Guys, this is not compulsory. You can directly involve e to the power x's and work with it. So you have here a square minus 4a plus 1. This is actually pretty basic, right? So I'm not gonna go with this because I feel like you guys are now doing further math, so you should be able to handle it. Okay, so basically I get here e to the power x equal minus b plus or minus square root b square minus 4ac divided by 2a. All right, guys. So I directly substituted values to the formula and I'm getting the answer for e to the power x. Okay. So e to the power x equals 4 plus or minus. So we get here that's 16 minus 4. So that's a 12 divided by 2. So that's going to be e to the power x. 4 plus or minus square root of 12. That's going to be 2 root 3, right, guys? Whole thing divided by 2. So you can divide both terms by 2. You get 2 plus or minus root 3. So ex is equal to 2 plus root 3 or ex is equal to 2 minus root 3. All right, guys, are you with me? And now you can get the x value by taking the natural log of both the sides. Okay, so you can take the natural log of both the sides and get your answer. Okay, let's get the natural log of both the sides. And then you get here ln e to the power x. You can take the x forward. X times ln e, that x times 1 equals natural log of 2 plus root 3. All right, guys. And the other one, do the same thing to the other side. Take the natural log. Okay, so that gives you x times ln e, x equals natural log of 2 minus root 3. All right, guys. All right, guys. So this is the answer we got by working through it manually. So let's try to get the answer from the calculator as well. So I have here hyperbolic, and you can go for cosh inverse. Can you see, guys? We're trying to get the value of cosh inverse of 2, right? Right. I believe we're trying to get the value of cosh inverse. Yeah. So cosh x is 2, which means x is cosh inverse of 2. All right, guys. So cosh inverse, that's number 5, cosh inverse of 2. Okay, guys. And we get the answer here. So 1.316. I think I'm only getting one answer, right? So no matter how much I'm trying to go, I'm only getting one answer here. Okay, 1.316. So let's see which one it corresponds to. So probably the positive answer here. Let's type ln 2 plus root 3. Yeah, so you can see 1.316. This is exactly corresponding to the positive, I mean the ln 2 plus root 3 answer here. All right, guys. Okay, so the negative answer. So you're not actually getting this in the calculator. Okay, right? So guys, let me explain to you. Okay, so in the next part of the lesson, actually, in the next section, so we will be discussing about the graphs of each of these hyperbolic functions. And guys, you'll be able to see why we get multiple answers, and I mean how I mean to get the extra answers, and also to see whether the answers make sense. Okay, so both these answers are valid. All right, guys. So it's not just because the calculator gave you the positive answer, that doesn't mean that it's only this is the only correct answer. But here the other answer is also valid. So in order to explain its validity, so I think in the next part we'll be going through the graphs. So it's important to have a good understanding of the graphs in order to I mean in order to understand, in order to have a good idea of why both answers are valid and and how it works. Those ideas are actually really important. All right, guys. Okay. All right, guys. And okay, so both the answers are valid here, and they ask you to give the answers correct to 2 decimal places, right, guys? So you can type it in the calc and get the answers 1.32 and minus 1.32 correct to 2 decimal places. All right, guys. Okay, so next I'll move to question number 8. They say find 2 decimal places the values of x for which such x is equal to 1 over 8. Okay, so right, let's move on to that. Such x is equal to 1 over 8, and we know such x is 2 over ex plus e minus x. Okay, so this is our definition of such x. All right, so let's get it. 2 over ex plus e minus x is equal to 1 over 8. Okay, because such x is equal to 1 over 8. So I make such, this is such x, it's equal to 1 over 8. So simply, it's time to just simplify and get a quadratic equation again, right? So 8 times 2, that's 16 equal ex plus e minus x. And the next thing you can do here is multiply everyone with e to the power x. And then you get here 16 e to the power x. Ex into ex is e to the power 2x plus e to the power minus x into e to the power plus x, that's e to the power 0. That's basically 1, right? So 16 ex e to the power 2x plus 1. So you get here e to the power 2x minus 16 e to the power x plus 1. All right, guys, it's a quadratic equation, simply rearranging. Okay, so simply rearranging, and you need to check whether it factorizes. If not, you can directly get the answer by using the quadratic formula minus b plus or minus square root b square minus 4ac divided by 2a. All right, guys. All right, guys. So I get here 16 plus or minus. This is root. Yeah. So inside the root, you get here. I mean, when you simplify just the third alone, you get 6 root 7 over 2. So you can separate them out. 16 divided by 2, that's 8. Plus or minus 6 divided by 2, that's 3. So guys, you get here Ex equal 8 plus 3 root 7 or Ex equals 8 minus 3 root 7. And then guys, let's input the natural log. So ln e to the power x directly x. And here you get natural log of 8 plus 3 root 7. And here x equals natural log of 8 minus 3 root 7. So let's get the answer. Let's get the answer to 2 dp. Alright guys, so the answer correct to 2 dp, that's 2.77, and the other answer negative 2.77. Alright guys, so this is basically the simple or the basic idea behind hyperbolic function. Okay, so in the next part, we will move on to the more important and the graphical representations of this hyperbolic function.